Hello everyone. The title of my presentation is on optimized production assignment algorithm for custom-made garments. In recent years, many apparel companies have been downsizing their production facilities and specializing due to a decrease in both sewing manpower and the mass production base. To date, research on work management in garment production has focused on line balancing for ready-to-wear garments by mass production systems. The assembly line balancing problem, ARBP, of mass-produced clothing assign tasks so as to maintain the overall flow and reduce work delays, which enables the time required for individual tasks in the production line to be balanced. In mass production, the function level of workers is not considered in the task time because there is a fixed arrangement of processable workers per task. With the introduction of a flexible production system in 2000, researchers focused on solving the ARBP for flexible manufacturing systems, which differ from mass production systems, resulting in an analytical method being used to solve a mixed model ARBP. In custom garment manufacturing environment, task times can vary significantly depending on the skill level of a worker, and thus a different approach to solving the ARBP is needed. A small custom garment production process usually comprises 3 to 5 workers and produces a product for one order. Currently, there is a little research on efficient and economical production system for custom garment production. If such a system can employ the technique of mass production system, the result can be an optimal system for producing custom-made garments. Because custom-made garments are manufactured on demand, unlike mass-produced products, there are large variations in daily production. This is because individual garments vary in terms of fabric and design, which means the system must be sufficiently flexible to respond to such changes. In order to improve productivity and the quality of custom-made garments, it is necessary to organize processes efficiently by arranging production factories based on specific order, and then configuring the bundle units, task order, and so on accordingly. In general, the production of custom-made products requires a small number of workers, where one person uses various tools and performs different tasks. Therefore, it is necessary to allocate worker-specific tasks based on the functional skill level of a worker. The primary objective of my study is to develop a worker balancing algorithm to allocate tasks to each worker optimally when the number of workers changes, focusing on the number of workers in the production of custom-made garments. The development process of our worker balancing algorithm is like this. We first analyzed the standard process of custom-made shirts. The target company items are custom-made men's formal shirts, manufacturing on demand. The target shirt manufacturer's working time is 8 hours per day, and the worker makeup of 5-person team. 1 cutting, 2 sewing, 1 assistant, and 1 finishing. Sewing is divided into preparation and pre-processing and assembling and part making. Assembly and partial work are allocated to lock stitching sewing machine and special sewing machines. The company's current operation system was adapted to a multi-product, small volume production system and is operated as a straight line. However, each worker is responsible for various tasks and moving equipment as needed. In this study, we first analyzed the composition of shirts, composition of workers, the production assignment, and the task times at the site. Then we developed a worker balancing algorithm based on these data. In addition, we used the proposed algorithm to determine optimal balancing process. Next, we set the standard task time based on skilled workers. A standard task time is set by measuring the working time of 5 domestic skilled workers, all of whom have over 30 years of experience and can handle all kinds of sewing machines. The work consists of 5 consecutive cuts of shirt of the same design according to standard processes, and the task time is measured in units of 1 shirt. Next, we developed worker balancing algorithm. In order to develop a worker balancing algorithm, the type of task, difficulty level of the task, and the task conversion rules for each worker are defined based on custom-made shirts. The algorithm is developed using these variables and rules, along with the standard task time. In order to apply the proposed algorithm in practice, we organize work-specific tasks for 5-person team. Finally, we simulated and verified worker balancing algorithm. In this study, we use a timed Petri net to model the custom-made shirt production process and perform simulation using GPE and SIM tool in order to apply and validate the balance efficiency derived from the proposed algorithm. The labor utilization is calculated in the simulation, and then we compare the balance efficiency derived by the proposed algorithm with that of the existing system. Next, I will present about the development of algorithm. First, we analyzed the standard process. The standard process is set up according to the sewing order of the slim custom-made formal shirts, yielding 44 tasks, as shown in Figure 3. In custom-made formal shirts production, cutting is performed automatically by a laser cutter using patterns stored on computer. Because custom-made formal shirts differ in terms of size and fabric, in order to distinguish between cuts, a product number must be attached to each cut. Then, when each cut is separated and attached, there must be a process to check that the attached cuts have the same product numbers. Therefore, this step is included in the production process. The following machines are used in the production process: 4 lock stitching machine, 1 double felt seam stitch, 1 button sewing machine, 1 buttonhole, and 1 ironing machine. Next, we set the standard task time based on skilled workers. The average task time for a single shirt is 3,130. The average task time for each process is shown in Table 1. Next, we defined the variables and rules of the worker balancing algorithm. The production of custom-made formal shirts has 4 task types: cutting, assistant, sewing, and finishing. The task level can be estimated by taking into account of the period of training and experience needed for the task to be performed. In this study, considering the classification of the worker's task level, it is assumed that task level 1 can be performed with 2 months of training or experience, task level 2 with 10 years, and task level 3 with 20 years. The task level of the process for custom-made formal shirts production, the target of this study are set as follows: cutting A equal level 1, assistant B equal level 1, sewing C equal level 3, and finishing D equal level 1. Next, we developed an algorithm to optimize the production process according to the number of workers, based on the above-mentioned pre-data for customized production assignment and the conversion rules. The basic concept of the algorithm is to make the total task time divided by the number of workers closer to that of each worker's task time. The algorithm proceeds as follows. First, calculate the BPT, then determine the number of workers and the time per worker for the highest level task. Then determine the number of workers and the time per worker for the second highest level task. Then redistribute the time of worker for the highest level task and the time of worker for the second highest level task. In the algorithm, when allocating tasks to workers, the number of workers and the time taken for the highest level tasks are set first. This enables us to redistribute the work of a lower level task to workers of highest level tasks if the time of the low level task worker is set larger than the highest level worker's time. Assigning tasks to each worker is done in a way to assign as many consecutive tasks as possible so that workers can memorize the task and perform them more efficiently. The algorithm is based on several assumptions. First, the task type level is divided into 4 categories. Second, there are only 2 task levels, level 1 and level 3. Third, the lowest task level allows the task to be switched between workers even if the task type is different. First, a sewing worker can perform assistant tasks. Next is the detailed worker balancing algorithm process. In step 1, we calculated the wage pitch time, the time obtained by dividing the total process time by the total number of workers. In step 2, we determined the number of workers for C level 3 task. In step 3, we determined the task time of each C level 3 worker. In step 4, we determined the number of workers for level 1 tasks, A1, B1, D1. In step 5, we determined the time of each level 1 worker. In step 6, we decided whether to assign additional tasks to the highest level task worker. Now let's turn to the result. In this study, the algorithm is applied to the production of custom-made formal shirts. The resulting production assignment and balance efficiencies are presented in Table 2. In addition, the result of production assignment using the proposed algorithm for 4, 6, and 7 workers are shown in Table 3. Furthermore, we compared the results for 5 workers currently used by the shirt manufacturer and the results for 5 workers based on proposed algorithm. The result shows that the balance efficiency improves from 69.9% to 83%. See Table 4. The PetriNet model of this sewing process is shown in Figure 4. The conditions for the simulation of the production process of custom-made shirts are as follows. Number of workers 4, input lot size 5, input interval 50 minutes, operation time 2,400 minutes, task assignment scheduling, first in, first out. The balance efficiency of 4 workers by the above production assignment method is 92.1%. which means that the production assignment of each worker is equal at level of 92.1%. Therefore, the balance efficiency in mass production, in which a fixed worker is assigned per task, is theoretically matched with the machine utilization. However, the balance efficiency using the proposed method of assigning each worker to multiple tasks can differ owing to the waiting time of the task. The labor utilization of the worker calculated by the simulation is 90.2%, which is similar to the balance efficiency. Thus, an error of 2.1% indicates it is reliable. This is discussion and conclusion. This study developed a worker balancing algorithm for custom garment production, focusing on custom shirt manufacturing. It collected production data and categorized the task and difficulty level. The algorithm significantly improved the balance efficiency by evenly distributing workload among workers based on task type and worker ability. Unlike typical mass production line balancing, this study addressed the unique challenges of small-scale custom garment production. It presented a method to equalize task times while considering worker capabilities and task complexities. The results were applied to custom shirt manufacturing involving 44 tasks, 5 workers, and 2 task levels. Further research should expand to include various custom garments and task complexities to further refine the algorithm effectiveness and applicability. Thank you.